Okay, first, thanks for the kind invitation. It was a pleasure to attend this great workshop. And Sylvie Menezo, founder and CEO of Next-Gen Photonics, a startup I founded from CLAT with the ambition to exploit laser-augmented silicon photonics circuit technology.
Sylvie, thank you so much. It's great to have you here, especially since you've spent quite a number of years in this industry and have seen it evolve over the last 5 to 10 years quite significantly. So this discussion about modulation and lasers also points to another question that comes up often in this discussion about how photonics will scale for I/O. And that's the question of, should the laser itself be internal to the device, or is it better if it's external? Can you comment on those cases where an internal laser source might be a better fit and where an external laser source might be a better fit?
For pluggable optics, integrated lasers makes sense because you don't, in these pluggable optics, the temperature environment is friendly for a laser. But as you move the optics closer to the ASICs requiring high I/O throughput, the temperature gets higher, and this is not a friendly environment for the lasers. So mostly we work on two types of circuits: fully integrated circuits for pluggable optics, and we showed multiple of 800G. So you need 8 lasers, multiple, and if you want to do 3200G, you need 32 lasers. So integrated lasers make real sense. While when you go to co-packaged optics, again, remote lasers are preferred. They are like electrical power supply, but it's optical power supply. They are in a safer environment as compared to an environment closer to the ASICs, and they can be semi-cooled, so they can operate with higher power, higher wall plug efficiency, and you can supply many more wavelengths. We call them DWDM wavelengths. So then you target frequency spacing of 100 gigahertz to feed some modulators which are sitting close to the ASICs.
One thing we talk about often at Applied is something called high-value problems. These problems that are really important to be solved to help the industry move forward. Certainly we've heard from many that being able to do a passive high-fiber connect is one of those problems. We've also heard that being able to integrate the optics and electrical packaging is similarly very, very important to make the industry able to move forward. From your perspective, what are the big high-value problems? What are the things that you think need to be addressed, and in particular that you think Applied may be able to help address?
Yes, I think fiber optical connectors for co-packaged optics is a key element that the industry is working on. Laser also is another key element. High temperature lasers and packaging is also very key. We talk about optical connectors, but for serviceability, electrical connectors also would be required, I guess. Yeah, because then your optics, when it starts to be as costly as the ASICs itself, and for serviceability, you might want everything to be connectorized, including you want optical connectors, but maybe also electrical connectors, which is another challenge, I think. Power management, heat dissipation management. I think the co-package movement or co-package is a real challenge, is a packaging challenge. But as soon as you change the packaging, you need to closely co-design with the photonic ICs or the ICs, so that's a multi-partner collaboration requirement.
As you may be aware, Applied has many capabilities beyond just our historical focus on process and thin film tools for semiconductor manufacturing. We now have added our own packaging capability, optical materials and processing capability. And we're also very committed to investing in this ecosystem and watching it develop and be available to everyone so that there can be much broader adoption. Based on this additional direction, this new area where Applied is making these contributions, what do you believe would be most valuable to you as a company, and what do you think is most valuable to the ecosystem?
Heat dissipation, not only for photonics but also for electronics. I think because we want higher bandwidth density, higher integration density, but the power per square inch keeps on growing and growing. So heat dissipation is really key. Yes, I think fiber optic attachment contributing to equipment, also helping in reducing fab variabilities. That's so it can be at the substrate level also, but also at the fab levels. Anything that can be gained in terms of anything that can be gained in reducing variability is also key for having lower power circuits. I'm really impressed by the position of Applied as an equipment vendor. I'm really impressed by. I was not aware that you can shine over the whole supply chain like this, and we see your footprint everywhere. So that's very impressive what you can do at the equipment level. Usually when I'm at the component level, so not at the very top of the supply chain for sure, but usually we see how system can shine over the rest of the bottom supply chain. But here we can see how you shine, although you are at the equipment level. How you can shine on the top, to the top of the supply chain. So congratulations.
Sylvie, it was wonderful having you here today. When you come to an event like this, what is it that is most valuable to you? I mean, you go to conferences and you're interacting with many folks. Why was this a particularly helpful event for you and your company?
I think so many contributors from all over the world. Myself, I'm from France. I'm a bit jet lagged. That's why I might be confused in my explanations. But so many contributors from all over the world. It's in one day you can see state of the art at the academic level, at the industry level, and that's great because you can. For sure, you can meet people to collaborate with, and you can also benchmark yourself. Where do we stand as compared to what's going on all over the world? So that's a great workshop. Thanks for making it. Because you get to discuss with people, right after the sessions you have these breaks that allows you to discuss and exchange cards. And and in one day you get a good overview. You don't have to spend a week or and select your papers. I think you made a great setup, great overview. I follow tightly the state of the art, and I think you got a very good sample of what's going on everywhere. So thanks for the invitation.